Today we're going to be working on converting fractions to decimals. Here's the thing with fractions and decimals. If you read fractions correctly, they are going to read exactly like the decimal, which makes them a lot easier to convert. So what we know about decimals, place value in decimals, is that after the decimal, in the first decimal place, you have tenths. So this is going to be fractions that have 10 in the denominator. The next is hundredths, and that is going to be where we have 100 in the denominator. Then we have thousandths, and that's when we're going to have 1,000 in the denominator. So if we can convert a fraction into tenths, hundredths, or thousandths, it's going to read exactly like the decimal, making it very easy to convert. So when you look at a denominator, if it can easily mentally be converted into tenths, hundredths, or thousandths, we can do this mentally. For example, here with 2/5, I know with 5 that tenths is the first decimal place we want to go to, and I know that I can go 5 times 2 equals 10, so I can mentally go 2 times 2 is 4, so I know that is 4/10. I made it into an equivalent fraction with the denominator of tenths. Now when I turn that into 4/10, it reads exactly like the decimal, 4/10. So it makes it very easy to convert into 4/10. So this is what our goal is, and this is what we're trying to do. If you can easily convert the fraction into tenths, hundredths, or thousandths. Okay, here we have 20. 20, we have tenths, hundredths, thousandths. Well, 10 is too small, but I can go up to 100, and I know that 20 times 5 is 100, and 7 times 5 is 35. So I've changed that fraction into an equal fraction of 35 hundredths, and now that it's written that way, it reads exactly like the decimal of 35 hundredths, which is 0.35 when you write it. When you read a decimal, you read this number, 35, and then you say the name of the last place value that's present. So that is 35 hundredths. Okay, this one with a denominator of 125, well, that's greater than 10, greater than 100, but we can do 1,000. I know that 125 times 8 equals 1,000, so I would multiply this times 8, and that would be 24 1,000ths. Now, if pretty much for the fractions of 1,000, you're going to have fractions counting by 125s. 1/8 is 125, 125 hundredths, 125 thousandths, sorry. And then if you can count by 125s, it's going to make this easier. That would be 250 thousandths, which is the same thing as 25 hundredths. Then it would be 375 thousandths. That would be 3/8. And 4/8 would be 500 thousandths, or just 5/10. Then we would have 625 thousandths, 750 thousandths, which is the same thing as 75 hundredths, and 875 thousandths. If you can count by 125s right here, this is going to make your fractions of eighths a lot easier. That's just kind of an aside. 24 thousandths. So how do we write that? Since we want the last number to be in the thousandths column, we have to put the 2 here, and we have to put the place 0 here for that to read 24 thousandths. 1/2, I can make this a denominator of 10. 2 times 5 is 10 in the denominator. 1 times 5 is 5. 5/10 can easily be written as a decimal 5/10. I hope that you are writing some examples of these on the inside flap of your notes. Okay, here's another one, 7/50. I can easily make that into a denominator of 100. 50 times 2 is 100, so I multiply 7 times 2 to get 14. That would be 14 hundredths. So when I write it, I have 14 with the 4 being in the hundredths column. 10 25ths, I can make that into 100ths. I know that 25 times 4 equals 100, so I multiply the top by 100, and that would be 40 100ths. So when I write that 40 hundredths, will be the same thing as 4 tenths, or 40 hundredths. Now, many fractions you cannot write, you cannot convert them into an equal fraction with a denominator of 10, 100, or 1000. So it may be necessary to take your calculator at this point and do what it says. This actually says 3 divided by 8. But a few minutes ago I was talking to you about eighths. Eighths is going to be the denominator that you're going to use to do thousandths. So again, if you can count by 125, 250, 375, 500, 625, 750, 875, and 1000. This one is 1/8. 250 is 2/8. 375 is 3/8. 500 is 4/8. This is 5/8. 6/8, 7/8, and 8/8. So when you have eighths, you know you're going to be counting by 125 however many times the numerator is. So since this is 3/8, I would count by 3, or I would count by 125 3 times, and I would see that that is 375 thousandths. If you didn't know that, you can take your calculator, but it may do you well to memorize the eighths, the 1/8, the 2/8. If you can count by 125, you're going to see these a lot, and it would do you well to memorize them. 3/16, I cannot make this into a denominator of 10, 100, or 1000 mentally. I can't take it to eighths because that would be 1.5 on top. So here I'll probably just want to take my calculator and go 3 divided by 16. And when I do that, I find out that it is 1,875 10,000ths. Here's another eighth, 7/8. So I would count by 125 7 times, or I know that it is 125 less than 1,000, or I could use my calculator. Either way, it's 875 thousandths. Here's another eighth, 5/8. So I would count by 125 5 times, or I could take my calculator, and it would be 625 thousandths. Again, you see that this is eighths are used a lot, so it might do you well to memorize them. 3/8. If I count by 125 3 times, that would be 375 thousandths. So just to back up, that's making this into thousandths. This would be times 125, so we're multiplying this times 125. We're counting by 125 3 times. These decimals are all called terminating decimals because the remainder is 0. Now what do I mean by that? Let's go back here. This actually says 3 divided by 8. So if I were to do long division and I were to do 3 divided by 8, I can't go 3 divided by 8, so I'm going to start adding 0. So I add my decimal to 0. So I have 30 divided by 8, and that goes in there 3 times. 3 times 8 is 24. When you subtract, you get 6, and I have to add another 0 and bring it down. 60 divided by 8 would be 7. 7 times 8 is 56. When I subtract, you get 4. Add another 0 and bring it down. You have 40 divided by 8 is 5. Now watch what happens right here. 8 times 5 is 40. When you subtract, you finally get to 0. This is what a terminating decimal is. It means if you carry out all the steps of long division, eventually you're going to get to where when you subtract, it gets to 0. And that's the point that you're done with the decimal. So this is what a terminating decimal is. The remainder eventually is 0. Eventually, in the process of long division, you're going to get to 0. Now, there are some decimals that you could go on forever and ever with long division, and you're never going to get to 0. We're going to write the decimal. Some of these have a repeat in it. Let me show you what I mean by that. First of all, if you were to take your calculator and you were to go 5 divided by 12, I don't know if you have a calculator handy. So if you were to take your calculator and go 5 divided by 12, you would see that your calculator would read 0.41, and then there's going to be a succession of sixes, however many windows that you have. And then a lot of times at the end it'll say 7, not because 7 is the next number, but because your calculator is going to round the last digit on the screen. And so since 6 is more than 5, they round that last digit up. So you can pretty much ignore that. But that means that if we were going to go 5 divided by 12, and you started this long division process, you would do 4, and that's 48. 2, you bring down another 0, that would be 1, so you do 12. Subtract and get 8, bring down another 0. Here's where you're going to start a loop. It says 80, which would be 6. 6 times 12 is 72. When you subtract, you get 8 again. Here's where the loop starts. And you bring down a 0, and you get 6 again. And then you get 72, and you subtract and get 8 again. You're going to be in this continual cycle loop of this long division where it keeps doing, when you subtract, you get 8. You bring down another 0, and it's 80. So this decimal is going to repeat on and on and on. Now, how do we write that when it's a repeating decimal? We use a line over the digit that repeats. So since the 6 was the digit that was repeating over and over again, we put this line over the top of it to show that it was a repeating decimal. 2 divided by 11. If you were to do that with your calculator, you would see that you have 1, 8, 1, 8, 1, 8, 1, 8. You can see that the repeat is 2 digits that repeats over and over again. So when we write that decimal, we're going to write it as 1800ths, but we're going to have this repeat line over it, which means that that 18 is going to continue in a loop. 7/9. If you do 7/9, 7 divided by 9 with your calculator, you will see that that says 0.777777. At some point it may say an 8 because that last digit is rounded up. Now, ninths is another fraction you probably want to memorize. If you were to take your calculator and do 1/9, 1 divided by 9, you would see that it's 1/10 repeating. 2/9 is 2/10 repeating. 3/9 is 3/10 repeating. You see a pattern going on here? 4/9 is 4/10 repeating. So here's what you need to know. 7/9 would be 7. It looks like 7/10 are a repeating line. This here is 7/9. Because of the repeat line over the top, we know that this 7 is repeating over and over again as it does with ninths. But if you see this without the repeating line, this reads 7/10. This fraction reads 7/9. The difference is in the repeat line on the top. And you need to know the difference between ninths and tenths. So tenths is when you just have one digit in the decimal, like this, like 5/10. But anytime you have only one number in the decimal with a repeat line over it, that actually says 5/9. So this is 7/9. So this decimal, although you might want to read it as 7/10, you actually read it as 7/9 because this repeating line over the top tells you that it repeats and that it is ninths. This continues on with 99ths. So if you were to take 17 divided by 99 on your calculator and look to see what happens, you would see that you would have 17 repeating over and over again. So if all of the digits in the decimal are repeating, the 1 and the 7, and it's 2 digits, you know that this says 17/99. Here's the decimal for it. This, because of the repeat line over it, you know it's 17/99. If you saw this decimal, this one reads 17/100ths. The repeat line makes the difference between 99ths and hundredths. And this keeps working even with 3 digits, with 999. Okay, that's 1 less than 1,000ths. So this decimal would read 437 thousandths, but if you put the line over it, all three digits, all of the digits in the decimal, it reads 437 999ths. So when you're involving 9 or 99 or 999 or keep going up and all of the digits are repeating, you know that it's not tenths, one hundredths, one thousandths, but instead it's 999, 999 thousandths. If you were to do 1/12, you would take your calculator and you would divide 1 divided by 12. You would see that it's 0.08, and then the repeating begins, 3, 3, 3, 3, 3, 3, 3. So it's only the 3 that repeats. So when we write that, we have 83 hundredths with a repeating 3. 7/30ths, if you were to do that with your calculator and do the division, you would see that it says 0.2 with a repeating 3. So how do we write that? We're going to write just 23 hundredths, but show that the 3 is going to continue to repeat. So you put the line only over the digits that repeats. Now we can take this knowledge and we can compare fractions and decimals. With fractions, you can either make common denominator, you can also do cross multiplication, or you could turn them into decimals. So I'm just going to show all of them to you. First, if I were to turn this into a decimal, 3/5, I know I can make that into tenths. That's times 2 and that's times 2. That would be 6/10. That doesn't really help me though because I can't make this one into tenths. So if I were to find common denominator, that would be 20. 5 times 20 is 4, so I multiply this times 4, and that would be 12/20ths. I make this into 20ths. 4 times 5 equals 20, so 3 times 5 equals 15, and now I can compare and say that 15/20ths is greater. What also works when you're not dealing with mixed numbers is you can multiply by diagonal. 3 times 4 is 12, and right over the top of the numerator. Multiply this diagonal. 3 times 5 is 15. Notice we have the same numbers that we had in the numerator of our common denominator fractions. So I can just compare it this way and say less than. You can do that if it's not a mixed number. If one is a fraction and one is in decimal, you're either going to have to convert the decimal to a fraction or the fraction to the decimal. If I go 2 divided by 3, that is the same thing as ninths. This one's times 3 for ninths. This one's times 3 for ninths. That would be 6/9, and I know that 6/9 is written like this, and that is less than 7/10. So the more you know about fractions and decimals, the easier it is to compare them like this. 1/8, I remember that eighths is counting by 1/25, so that's 125 thousandths. And when I compare that to 12 hundredths, this has an invisible 0 after it, so I have to compare to the thousandths column, and 1/8 would be larger because of that 5 in the thousandths column. When you're ordering numbers, and some are decimals and some are fractions, again, you can convert them all to fractions or all to decimals. I know that 4/9 is 0.4 repeating, so that'd be 0.44444 continuing on. 2/5 is the same thing as 4/10, which is 4 with zeros after it. I'm just showing you the digits that are after it so that we can compare. So from least to greatest, what is the smallest? We see that 2/5, which is 0.40000, but when I write it, I want to write it with the original fraction, not with the decimal that I converted it to. The next one would be 4/9, which when repeated out is 0.44444 forever and ever. So I'm going to write 4/9 back in the original fraction. And then 5/10 is the last one. So when you write them from least to greatest, write them back with the original fractions or decimals that they gave you, not to what you converted them to. So the more you know about converting them, the easier it is.